So what we're going to talk about, a totally new section now. We're moving into a whole new arena. Okay? There's still a lot of similarities because we're going to be talking about equations like we've been doing before. In particular, equations with two variables, x's and y's. However, it's called, what we're going to talk about is systems of equations. Sometimes people will call them, you'll see them in textbooks as saying linear systems. What's linear mean? Does anybody know?
Like line.
Line. What kind of a line?
Oh, straight line.
Linear means straight line. Exactly, right? Straight line. So we're talking about equations with straight lines. Linear systems. Notice it's plural. Okay? Notice systems of equations is plural. And another term that you will sometimes see if you use Saxon ever, they call them simultaneous equations. Actually, that's my favorite term, but it's not used very often, so I don't use it very often. But I like that the best because that makes the most intuitive sense of what we're talking about. We're talking about more than one equation simultaneously at the same time on the same graph. Okay? So we're actually going to be dealing with more than one equation at a time. And we'll be graphing them on the same graph. Okay? In particular, we're just going to focus on two equations at a time. We're not going to go to 3 or 4 or 5. We're just going to deal with two equations. But all of those would have been considered systems of equations. Now, why systems? Why do they call it a systems of equations when you have multiple equations? How many people know what a stereo system is? Right, everybody does, right? Stereo system. You got one at home. What is a stereo system? What's in it?
Plays music.
Well, it plays music. You got. What do you need to play the music though?
Speakers.
You need speakers. What else do you need?
A brain.
You need a brain. You need speaker wire, right? You need speaker wire to go from the tuner or whatever to the speakers.
You need that.
You need
electricity.
You need electricity.
You need a DVD.
You need a DVD player, right? You need a lot of things. You need surround sound. You might want to have a woofer, right? You might want to have a DVD player so that you can also watch your movies with surround sound, right? That's all considered a stereo system. It's more than one thing. Does that make sense? A system is a group of things, all that work together. Well, systems of equations just means more than one equation that are working together. Now, we're going to actually be talking about solving systems of equations. And I'm going to actually write a problem down right now. So I'm going to ask you to solve this system. Solve the system. Make sure this is in your notes. Today is the 24th, right? 1/24, 17. All right, so here's my system. I've got x plus 2y equals 7. And 3x minus 2y is equal to 5. All right. Now, I have two equations, and I want to graph them. I'm solving this in particular by graphing. There's 3 methods of solving these, and the first one is graphing. It's not the most accurate way, and it's easy to make a mistake with it because you've got to be really precise when you graph, right? You know how, like, if you have two dots, if you're graphing, you've got a dot here and a dot here, it would be really easy to make the line be like this, or to alternate, just slightly move it this way or slightly move it this way. Harrison, you get the idea? Like this line, if I had 2 dots close together and I'm trying to draw a straight line, it'd be really easy to go through those 2 dots and have, by the time I get out here, I'm radically off, right? One line might be, here, and the other one might be here, right? And so I need to graph extremely precisely in order for this to work, to solve the systems of equations. So, unfortunately, I don't have graph paper on this board. It's in the other room, maybe that other board. But so let's try it though. We're going to try to graph this. And I chose this in particular because it's also a little hard to graph. Now, remember, what form are these in? What form are these written in? There's slope, intercept, point slope, and standard.
Point slope.
Point slope is y minus y1 is equal to m times x minus x1. That doesn't, I don't see any parentheses. So it can't be point slope. So the other two options are slope intercept or standard form. Which form are these written in? Standard form. Standard form has your x and y on the same side. Slope intercept is that famous formula, y equals mx plus b, right? All right, so we know they're in standard form. How do you graph something in standard form again? Who knows? Who remembers? Anybody? X and y intercepts, right?
Oh yeah, no, I know.
Yes, how do you do
In
it, Tom?
standard form, so you make a t-chart.
Okay, so we're going to make the t-chart, x, y,
Yeah, okay.
and
then
when
you put
x is 0, and when y is 0, right?
then you cover one up.
Okay, cover one up. When x is 0, I'm going to cover it up, make it 0.
Alright, 2 times what is 7? Well, it'd be 3. But 3's not quite enough.
3.5, 3.5.
3.5.
So it's 3.5. Now this time we're dealing with a decimal, right? Sometimes you'll get these, sometimes you won't, but sometimes you do.
I don't understand how you graph a decimal. That's the hardest part.
You just put it in the middle.
And 7.
It'll just be, when it's a half, 3.5, it's a little easier than like if it's 3 and, 2/7,
Yeah.
right? That's hard.
You
But
just put it right in
3.5
the
is
middle.
pretty easy, right? It's right in the middle. Okay, now what about this? When y is 0. So this minus 2y, I'm going to get rid of that. Oh, wait a minute. What are we doing? Oh, wait, we're just graphing this one. Sorry, we're graphing this one. So we did that. Okay, so when y is 0,
7.
and then x is 7. So now I got to graph that. So here we go. 1, 2, 3, 4, 5, 6, 7. Okay? And then 0, -3. 0, 3.5. Oh, wait a minute. What am I just doing? 0, 3.5 is right here. 1, 2, 3.5. So there's my first one. And then 7, 0 is 1, 2, 3, 4, 5, 6, 7, top. So here we go. So there's my graph. And ideally, I should use a ruler because it has to be extremely accurate. Extremely accurate. You guys taking notes? All right, now for this one, I've got to do this one. On the same graph. If I have a different color, I'll use it, but I don't know if I do. Looks like I might. All right, we use red. Okay, so here we go, red. So if x is 0, and when y is 0. When x is 0, y is what? We're going to divide -2y equals 5, divide by -2. Y is equal to -2.5. Am I right? So 2.5 negative. When x is 0, when y is 0, 3x equals 5. 3x equals 5, divide by 3, divide by 3. X is equal to 1 2/3. 1 2/3. This one's hard. This one's a harder one to graph, right? Don't you agree with me? This one's going to be kind of hard. Well, let's try it. So we got 0, -2. 1, -2.5. So it'll be right there. And then this one is 1 2/3, 0. 1 2/3. It's going to be somewhere around there. Right? So now, if I graph this, if I draw a line for this, again, I should be using a straight edge when I do these, but I don't have one right here, so it's not. What would you think, intuitively, what would you think would be the solution to this systems of equations? There's one point that is a solution to this system. Look at the graph. what would be the one point that you could imagine would be the,
This is just kind of
yeah,
guess,
guess.
but where they intersect.
Yes, exactly, that's totally it. Right, this point right here, where the two lines intersect, is what you're looking for when you're actually being asked to solve a systems of equations. So the problem is, what is that point? I have to guess what that point is. If I had graph paper, it would be a lot easier. Does that make sense? But without graph paper, I'm not sure. I'm going to guess. It looks to me like it's over 3. So it looks to me like it's 3, comma, 3, and then 1, 2. It looks to me like it's 3, comma, 2. Do you guys agree with me?
Yep.
Doesn't that look like 3, 2? All right. That's my guess. Question.
It almost looks like 3 and a half, 2.
It could be. If it turns out to be 3 and a half, 2, it starts getting harder because it could be 3 and 1/64th, comma, 2 and 1 millionth. You know what I'm saying? It could be anything if it becomes a fraction. So what I'm going to try is I'm going to try whole number points. Does that make sense? And if it works, if it's true, then I've found the answer. But if it doesn't work, then I just say cannot easily be solved by graphing. Okay? There are algebraic ways to solve them that work every time. Okay? So now, the thing is, I don't know. Do we know for sure that 3, 2 is the answer? We don't. How would we know? How could we know for sure? Gavin.
Solve it algebraically.
Solve it algebraically, but could we take this? Isn't this an x? And isn't this a y? Couldn't I substitute those into my original equations and see if I get a true statement, right? You know what I'm saying? So let's try it. Well, you'll see what I mean when I do it. So here we go. We got rid of this. We have two equations. I'm going to first write this one. X plus 2y is equal to 7. I want when x is 3 and y is 2. I want to know if I get a true statement. If I do, then that point is on this line. Does that make sense? So let's try it. So x is 3. 3 plus 2 times y. 2 times 2 is equal to 7. 3 plus 4 is equal to 7. 7 equals 7. That is true. So yes, this point is on this line. Does that make sense? You see what I did? I just took the 3 comma 2, the 3 is my x, the 2 is my y, and I plugged it in to the first equation. That's the first equation. Now I got to try it with the second equation. Second equation. It's 3x, yes, minus 2y equals 5. All right, so x is 3. 3 times 3 minus 2 times 2 is equal to 5. 3 times 3 is 9. Minus 4 is equal to 5. Is 9 minus 4 5? 5 equals 5. That worked. If it said 5 equals 4, then it wouldn't work, and there is no easy solution by graphing to the systems. But since both of them worked, I know this point, 3 comma 2, is on both of these equations. All right, does that make sense?
Yes.
So the first thing, let's think about what we did. Number 1, our steps, just so we have them down, and then we'll try one more. That'll be a little easier. The first step, our steps. Okay, number 1, graph each equation. Oops, I'm running out of space. Graph each equation. Number 2, estimate best answer. In other words, the point. You know, take your best guess at a point. And number 3, substitute into both, well, x and y into both equations. Okay, and the last thing is, if both are true, you know what I mean by that? Both are true. Like 2 equals 2. Right? See here? We got 7 equals 7. That's true. If it came out as 7 equals 13, then I know that point is not on this line. Does that make sense? And when it says 7 equals 7, that point is on this line. It is a solution to this equation. Right? If it's a solution to both equations, then it is the solution to the system, to both equations, right? So if both are true, comma, then that point is the solution. And then the last one, if one is false, then it is not a solution. To the system. Make sense? So we graphed each equation. We figured out what we thought was the best estimate of that point. And that point has an x comma y. We substituted those x and y's into the original equations. And if we got true answers on both of them, then that point is correct. Then we found the solution to the system. If both of them, if one of them worked and the other one didn't, then we did not find the solution. Does that make sense? Because the solution is only true if it's true for both of them. That's what a system is. It's got to be true for every piece of the system. Okay? This to 5. Am I totally losing you? I can't quite tell.
I think I really get it.
Okay, awesome. So let's try another one that's not quite as hard. That one I just took right out of the book, and they chose one that was kind of hard to graph. But let's leave up our rules. Oh. Okay, solve the system. Okay, let's try one more. 56. One more. That's easy, that's easy. Okay. That's easy. Let's do one, let's do one that's in, okay, we'll do this. We'll do x minus y equals 5. And then we'll do y is equal to negative 3x plus 3. Now notice, in this case, they're not in the same form. This is in standard form, right? Right? This is standard form, and this is what form? Slope-intercept, y equals mx plus b, right? Okay, let's graph them. Again, we got to graph them really carefully, really carefully. So I know for the first one, I'm going to have to use my x, y intercepts when x is 0 and when y is 0. When x is 0, negative y is 5, therefore positive y is negative 5. Right? You guys know that? If negative y is 5, I could multiply both sides by negative 1, and positive y would be negative 5. Right? If y is 0, x is 5. Well, that's easy. So 0, negative 5. 1, 2, 3, 4, 5. Okay, and then 5, 0. 1, 2, 3, 4, 5. Boom. And I've got to draw a straight line. It's going to be about that. All right, we'll use another color for the next one. This one is in y equals mx plus b, so I just go up 3. 1, 2, 3, put a dot. And I go down 3 over 1. Down 3 over 1, put a dot. Down 3 over 1, put a dot. I'm guessing that that's this point. Right? Boom. I'm going to guess that that point is over 2, down 3. That's my guess. 2, comma, negative 3. Don't you think that's a safe guess? If it's 2 comma negative 2.5, I would say it's not worth trying. You know what I mean? I'd rather just deal with whole numbers here, right? And let's just see if it works. I'm going to plug them in now to each of these. So the first one, x minus y equals 5. My x is 2, my y is negative 3. X is 2 minus a negative 3 equals 5. 2 minus minus 3, 2 plus 3 equals 5. Is that true? Yes. Okay, it works. All right, let's try the second one. Y equals negative 3x plus 3. And y is negative 3 equals negative 3 times 2, because x is 2, plus 3. So negative 3 is equal to negative 6 plus 3. Negative 3 is equal to negative 3. That worked. So we know it. So this is the solution. And so I put that point in a box and I'm done. Okay. Does that make it easier? Was that a little easier to see once you saw the second one? All right. So I think that's all I'm going to do for this now.